Here's an example problem involving a concave mirror with the object located outside of the center of curvature, or outside of twice the focal length. Just to kind of give you an idea of where the location of the image would be, we'll take a look at the three principal rays that you can draw. One ray, remember, comes from the object, and a ray coming in parallel to a concave mirror is going to come out passing through the focal point, like this. Here the focal point is at the 5 centimeter part. Okay, another principal ray is a ray which would come and pass through the focal point, and a ray which passes through the focal point is going to leave the mirror and come out following a straight line like this. And then one other ray which can be drawn would be a ray which passes through the center of curvature, and a ray which passes through the center of curvature is reflected directly back on himself like this. All right, and what will happen is that crossing point will locate the image location. So what we would get is we would get the candle flame right here, and we would have an upside down image of the candle drawn in that location, and that's approximately at a point 7 centimeters in front of the mirror. This would create a real image because the light is really crossing at this point. If we put a piece of paper there, we would see the image of that candle. If we were going to calculate the exact location, we could use our equations. And we can see that our object distance, if you count the object distance here, P, is equal to 17 squares, we'll say 17 centimeters. So using our formula, we would have 1 over 17 centimeters plus 1 over Q. We're looking for the image location, and that is going to equal 1 over the focal length, and the focal length is 5 centimeters for this drawing. Solving for 1 over Q, then we would have 1 over 5 minus 1 over 17 centimeters. And solving that on your calculator, we get 0.1411. And when you invert that, Q is going to equal 1 over 0.1411, and that is equal to 7.08 centimeters. So with 7.08 centimeters, we can see that Q is positive. That's a positive value, which means it's a real image and it's located in the front of the mirror. The magnification is equal to negative Q over P, and we could measure the size of the image, and that would be equal to negative 7.08 divided by the object distance, which is 17. And so if you take 7.08 and divide it by 17, that gives you magnification of 0.42, and that would be negative. The negative sign indicates that the image is inverted, okay, and 0.42 means it's approximately, it'd be approximately half the size, a little bit less than half the size. And that's how you do a problem involving an object outside of 2 focal lengths for a concave mirror.